Hello, my name is Yuri Kovalyonok. I am from Russia, Republic of Crimea. I work physics teacher in school. Forgive me for my English. And I want to solve a physics problem in mechanic. Now on the screen you will see the condition of the problem which is used in Russia in the final exam at school. We must write down the condition of the problem. Given V0 equally 500 meters second, V equally 2 times V0, T times 100 seconds. We need to find the mass ratio M1, M2. We need to find this. Problem solving. To solve the problem, you need to make a picture. And this is maximum height. V0. At maximum height, the projectile exploded into two equal parts. Part 1 where 1, 0, and part 2 where 2, 0, vector, vector. YS before and after. And momentum before the explosion 0. Use the law of momentum conservation. 0 equally minus M1 where 1, 0, M2 where 2, 0. This minus protection of the vector in the axis or Y. So M1 where 0, 1, 0 equally M2 where 2, 0, and M1 M2 equally speed where 2, 0 where 1, 0. I hope you know this law and understand what I am taking about. From this we can conclude that. So sorry, my English is very bad, and we have to find the speed where 2, 0 and where 1, 0. If we find the speed, we find in the mass ratio To solve the problem correctly, I will do more drawing. This is maximum height, and we find the speed of the first piece of projectile. M1 where 10 after explosion, M1, and this where speed vector, and find speed of the first piece of the projectile. To find the speed, you need to know the height, and I will find the maximum height before the explosion using the law of conservation of energy. So this kinetic energy equally potential energy, and kinetic energy and potential energy. And maximum height equally where 0 2g and 12,500 meters. To find the speed of the first piece after the break, you need to make the kinematic calculation of the object, which the acceleration down to the edge. And maximum height we 10 T1 GT and 10 GT, and the solution you will find on my channel in Instagram. I let the mathematical solution and write immediately the answer. For 10 equally and this each 166 meters seconds. To find the speed of the second piece after the break, you need to take another picture, make up the kinematic calculation for moving the object vertically upwards. To solve the problem correctly, I will do more drawing. Maximum height M2 T2 within the speed of the second piece, where choose 0 vector, and before explosion M2 parts. After the explosion, the second piece will rise to one even greater height, and this and this time T2, and this time T2. Rise time equals desert time, T2, T2, and where 2 0. Since we now we know the object movement occurs in a vacuum, and speed where 2 0, speed where 2 0, and this time T3. Using the condition of the problem, we know 100 seconds, and equally T2 plus T3, and we know the maximum height at the very beginning, and 12,500 equally where 2 0, and T3 GT 2, and we know maximum high speed equally 0, this 0, and where to 0, it's 0 plus GT, and we must solve the system of equations, this, and you can find the solution of the system of equations in my Instagram account, and we choose 0, where choose 0 equally 375 microseconds. M1 M2 equally where choose 0, where 1 0, and this so 0 points 43 hundredths. This the answer. M1 M2. Thanks for watching. Thanks.